Hi guys, so today is the tutorial session. We have done a couple of lectures. So we have learned like correlation analysis, different types of correlation analysis. We have learned regression analysis. So now it's time for tutorial. So in this tutorial, as like my previous tutorials, first we'll be doing few objective questions and then we'll be solving a bit bigger problems. Okay, so now coming to the objective type question, my suggestion is that please don't see the answer immediately. First try to think, and then if you cannot, then only you go to the answer. It's a very easy questions. First is, which of the following statements are not true? So are not true. Okay, so Pearson correlation analysis is applicable to only numeric data. Yeah, that is correct, right? Pearson correlation analysis is applicable to numeric data. Spearman correlation analysis is applicable to only cardinal data. No. What is cardinal data? Cardinal data is the numbers which we use to count numbers, right? 2, 4, 5, those are where we used to count some numbers. We call it as a cardinal number. Then chi-square test is applicable to categorical data. Yeah, of course, chi-square test is used for nominal data, that is categorical data. Then any non-parametric statistical learning approach is applicable when the entire population is known. Very true. When the entire population is known, or we have a very big sample size, unlike the parametric case. So here only one statement is wrong, that is B. Spearman correlation is analysis is applicable to only cardinal data. Spearman correlation analysis is applicable to what sort of data? It's data where there is an intrinsic ranking among the data, right? So that is ordinal data. Spearman, of course, we can use for numeric data also, like for ratio scale data, for interval scale data also you can use it. But then better is that we use for the ordinal scale data. When the numeric data, when we try using Spearman concept, we lose some of the information basically. So next question, the value of the correlation coefficient lies between. The value of the correlation coefficient lies between what? Correlation coefficient. So it lies between -1 to +1, isn't it? So because correlation can be, there can be negative correlations, there can be positive correlation, isn't it? So the value lies from -1 to +1. If there is a strong correlation between two variables, then the correlation coefficient must be strong correlation. When there is a strong correlation, then it will be closer to either -1 or +1. If it is a negative correlation, then it will be closer to -1. If it is a positive correlation, then it will be closer to +1. So for strong correlation, when it is closer to -1 or +1, weak correlations closer to 0. To measure rank variables, the following correlation coefficient is used. When we have to find a correlation between the rank variables, so which one? Rank variable is the ordinal data, right? Ordinal data is the Spearman. If the sample data in a chi-square test contains m rows and m columns, remember chi-square test, we form a column where there are independent the independent variable, we put it in the column, and the dependent variable we put it in the row, and so it is, we form a m cross n matrix. So then the degree of freedom, what will be the degree of freedom? Degree of freedom is m minus 1 cross n minus 1. So this is the degree of freedom. And so how many coefficients do you need to estimate in simple linear regression model? Simple linear regression model, what is the expression for simple linear regression model? Y is equals to alpha plus beta x. So what are the coefficient? Coefficient is alpha and beta. For simple linear regression, we need to estimate two coefficients. Okay. So the square of the correlation coefficient r, that is r square, will always be positive. Square of the correlation coefficient r, we have done an r square test. Remember what r square test where we do? And what is r square called? R square is called coefficient of determination, isn't it? So now we'll be doing some problems. Okay, so very easy one, just simple. If you know the technique, you know the formula, you'll be able to do it. Nothing much to understand here as such, just you have to understand what this, and some problem it is the direct straightforward, it is directly given, use this, and some you'll have to find out what we have to use, and accordingly you should know the formula for that. Now here, the owner of a shoe store wants to know if the shoe size and the weight are correlated in adult males. If the size of the shoe shoes and weights, if there is any correlation between them, the owner wants to know. So she measures the shoe size and asks the weight of 14 consecutive customers. For the 14 consecutive customers, what she took the weight as well as the weight of the customers as well as the size of the shoe. The shoe size are given in the table. Find Pearson correlation in this data. So it is just given, you have to find the Pearson correlation. So if you can remember the what is the formula for the Pearson correlation, you don't have to do anything else. Just put it in a formula, simple formula putting. So this is the Pearson correlation coefficient. What is the formula? Covariance of x and y divided by the standard deviation of x into standard deviation of y. Covariance of x and y. When we write covariance of x and y, this is the formula, this numerator what we see, and will be divided by the degrees of freedom. What is the degrees of freedom? Degrees of freedom is n minus 1, right? Similarly, standard deviation of x into standard deviation of y. So standard deviation is this, again under square root I will be having n minus 1, and here also under have root over n minus 1, here also I will have root over n minus 1. Here I just have n minus 1. So root over n minus 1 into n minus 1 is n minus 1. This n minus 1 gets cut. So what remains is this. So this is the Karl Pearson coefficient. This is the formula. If you cannot remember this formula, very easy. Just remember covariance of x and y divided by the standard deviation of x into standard deviation of y. Okay. So now what we need xi. From the table we will be getting xi value and yi value, and also we need x bar and y bar, that is the mean of x and mean of y. Just put it in the formula, you will get the r square value. Okay. So this is the r square value, r value, this PS correlation coefficient, that is 0.809. Now see here, from this value, what can you tell whether the correlation is a strong correlation or weak correlation? This value is closer to 1, right? So that means it's a strong correlation. Now again, do you also remember one thing, like this is the value, this correlation coefficient, we got it, okay, fine, but again we have to do the significance test also, whether what this correlation coefficient what we got is from a sample, right? This correlation coefficient what we got from the sample, is it also applicable to the population, or it's just by coincidence we got that? We have taken a random sample because samples are random, right? We have taken a random sample. In the random sample we got this correlation coefficient, but actually it is not so in the case of a population. So whether it is so, whether this correlation coefficient what we got in the sample, is it also applicable to the population? So we do the significance test. If you can remember that, significance test means we have to find out the null hypothesis, we find out the alternate hypothesis. What is the null hypothesis? There is no correlation coefficient, and alternate hypothesis is there is a correlation coefficient. Now if then we find here for Karl Pearson we use the t statistics. So we compute the value of the t, and for a particular significance level we see if the value falls in the critical regions, then we reject the null hypothesis. Remember? So anyway, here we are not doing it, is just asking for the correlation coefficient. So this is our answer, that's all. If if it has asked to find out whether this is it passed the significance test or not, then you will have to do that. Now the grades of class 10 students on the grades of 10 students on class 9 exam and class 10 examination in the English subjects are given in the table below. Calculate the rank correlation coefficient. Which is the rank correlation coefficient? Rank correlation means Spearman. Spearman we do it rank wise, right? So different students marks are given, 10 student marks are given for marks for class 9 exam and for class 10 exam, same set of students. Okay, same set of students, they are given marks for class 9 and class 10. So now we'll have to find out the rank correlation coefficient. So actually this question sounds a bit weird, right? The same set of students for class 9 exam and class 10 exam. Okay, take two different types of exam of the same subject. Instead of 9 and 10, take say for maths and science, that way. Okay, then how to find out the rank correlation coefficient? Rank correlation coefficient is this is the formula. Okay, so how do I find the di square? Di is the difference in the rank of two numbers. How do we give the ranking? Ranking highest number gets the rank 1, and the lowest number accordingly we come down. isn't it? So first we'll have to find out which is the highest number, and accordingly we give the rank 1, then rank 2, rank 3, and gradually. And then we will find out the difference of the rank of the two variables that we are trying to correlate. Is there any correlation between the class 9 marks and the class 10 marks? So we'll find out the difference of the rank. So once we find out the difference of the rank is DI, and what is N? N is the total sample size. So that's how just putting it in the formula we'll get the RS value. Now again for the significance test, what we'll do here, we'll be using this Spearman correlation graph is there, and for a significance level that I remember I told you in the class in the one of the lecture when we have discussing Spearman correlation, it is available in the standard textbooks, the graph for Spearman correlation. So from the graph, if you see if it falls in the rejection region, then there is no correlation between the two variables. So see here, so see the class 9, this is 98 is the highest mark, I have given the rank 1. After 98 it is 93, I have given rank 2. Similarly here 91 is the highest marks, I have given rank 1. So likewise, and then we find DI, then I find DI, then I find DI square, okay. Then accordingly put it in this formula and get the value of RS. Here it is just asks to find out the rank correlation coefficient, so we will not do the significance test. If it asks to find out the significance test, then accordingly you'll have to do it. Okay, so here the correlation coefficient 0.24, it's a weak correlation basically. Okay, okay. So this is a very interesting question. See here, the owner of a company provides pneumococcal is a type of pneumonia, basically pneumonia vaccine, in order to keep the sick leave count as low as possible. Okay. Due to vaccine shortage, at a certain point of time, only some of the employees received vaccine and others did not. Only some of the employees received vaccine and others did not. Fine. As a vaccine like COVID, there is a vaccine shortage initially, so all did not get vaccine, few got and few did not get. Then the company kept track of the number of employees who contracted pneumonia and which type of pneumonia each had. There are different types of pneumonia. The vaccine is for pneumococcal pneumonia. The vaccine is for pneumococcal pneumonia, but there are different types of pneumonia. So company is trying to keep track of the people who are contracting pneumonia and for what type. Are they contracting the type for which the vaccine they have given the vaccine, or they are contracting some other type of pneumonia. Okay. The data were organized as given below. So the company wanted to know if providing the vaccine made a difference. What the company wanted to know, that providing a vaccine, does it make a difference? That means by taking the vaccine, does it have any effect on the occurrence of the pneumococcal pneumonia? Does it have? By taking vaccine, that means we are having less number of pneumococcal pneumonia, or we are having having vaccine or not having vaccine, we are having the same number of pneumococcal pneumonia. That's what we need to find out. So this is very much a question of chi-square distribution. See, because these are the categories, different categories, and we have to find out the correlation of these two categories. What are the two categories here? We have to find out the different categories are the for the independent variable. If you see the different there's the vaccination status, that is the unvaccinated and the vaccinated. Does this vaccination status have any effect on the health outcome? Does this vaccination status have any effect on the health outcome? Health outcome, we have three different categories. Fine. One is sick with pneumococcal pneumonia, sick with non-pneumococcal pneumonia, and no pneumonia. So these are the three different categories for the dependent variable, and for the independent variable there are two different categories. So this is very much a question of chi-square distribution. That means we'll have to find a chi-square correlation. So we'll have to find out the chi-square value of this whole table, and then we will be able to tell it whether the providing the vaccine made a difference or it does not make a difference. So if the value that the chi-square value that we get, if it falls in the rejection region, then providing a vaccine really makes a difference. If it falls in the acceptance regions, that means providing vaccine does not make any difference. There is no correlation between the people contracting pneumococcal pneumonia, there is no correlation between people contracting pneumococcal pneumonia with whether they are vaccinated or not vaccinated. There is no correlation between these two. So we'll have to find, first thing is that we'll have to find out the chi-square value. Remember, in this table I have already told you in the class, the first thing is we'll fill in the table with the observed value. These are the observed value: 24, 5, 24 people caught pneumococcal pneumonia which are unvaccinated, 5 people caught pneumococcal pneumonia who are vaccinated. Similarly, 8 non-pneumococcal, 10 here for vaccinated, and this is no pneumonia is 61 and no pneumonia for vaccination is 76. So, we need to find out the chi-square value. So, for finding out the chi-square value, what is the first step? The first step is we will have to find out the row total and the column total, if you can remember. If you do not remember, I suggest please go through the lecture once again. So, first thing is that we will be finding the row total and the column total. This row total and the column total, we call it a marginal. So, row marginal and column marginal. So, this two put together is 29. This is the row margin of this row, and then the row marginal of this row is 18, row marginal of this row is 137. And similarly, the column marginal of this is 93, column marginal of this is 91. This is sum, and the total data is 184. So, now first we have the observed data. In the table we have the observed data, and then from our task is to find out the chi-square statistics. To finding out the chi-square statistics, first thing what we will have to do, our first step is calculating the row marginal and column marginal. Then after we calculate the row marginal and column marginal, then next step is to find out the expected value. Why we will find out the expected value? Expected value, how we will find? The expected value is that value which we will get considering that there is no effect on the vaccine. So, how do we find out the expected value? If the expected value is something that meaning that there is no effect of the vaccine or no vaccine, what value we are expecting that people will be contracting a particular type of pneumonia or people will not be contracting. So, to find out the expected value for each cell, this is the formula: row marginal into column marginal divided by the total number of values. Okay. So, now here for the this case, this is one cell, this is the second cell, this is the third, this is the fourth, this is the fifth, this is the sixth cell. Fine. So, now to find out the expected value for this cell, how do I find out the expected value for the row marginal into column marginal divided by the total number of values? You see what is the row marginal here 29 and column marginal here 93, 29 into 93 divided by 184. That is what we got it. 29 into 93 divided by 184, that is how we got the expected value. Similarly, we will have to calculate the expected value for each column. Well, let us do and see, because see here, this is the vaccination status. That is I think this is the first one is non-vaccinated, right? First one is non-vaccinated and second one is vaccinated, and this is this side we have row, we have the health status. Another one is first, let me just call it as a first category, second category and third category. First category is sick with that is pneumococcal pneumonia, and second is sick with non-pneumococcal pneumonia, and third with it stayed healthy, that means it did not have any pneumonia. So, for that, what was our observed value? Initial, I will make the whole table, that will be better actually. What was the observed value? Our observed value was initially this was 24 and this was 5, this was 8 and this was 10, this was 61 and this was 77. This was this was 76. This was 76. This is our observed value. First, I will write the observed value. What is the observed value? 24, and then we have here 8, we have here 61, and here we have 5, then 10, then we have 76. Okay. So, this this total is 93 and this total is 91, and what we have this total here is 29, and here is how much it is 18, and here how much it is 137, and total we have is 184. Okay. So, this is the observed value, this is the row marginal, and this is the column marginal. So, now once we get the row marginal and column marginal. Next we will find out the expected value. This is the observed value. Okay, this is the observed value. Next we will find out the expected value. Next we will find out the expected value. So what is the expected value for this? Expected value for this is 29 into 93 divided by 184. 184 is the total data. On this, if we calculate it, we will get this 14.66. I am just putting the data. You can calculate it afterwards. This you will get 9.10. This you will get 69.24, and for this 5 you will get observed value is 14.34. 14.34, this you will get 8.90, this will get 67.76, fine, 67.76. This is the expected value. Now, once we calculate the expected value, our next step is to calculate the chi-square value. What is, how do you find out the chi-square value? O minus E whole square by E. Okay, so this is the formula for the chi-square value. O minus E whole square by E. O is the observed value, E is the expected value. So when we calculate a chi-square value, we get a chi-square value is 5.95. For this is the chi-square. This is the chi-square, 5.95. This is this, we got 6.08. This we get 0.13. This we get 0.14, 0.98. and 1.00. So these are the chi-square value. So now we have to find out the chi-square statistic. Chi-square statistic means sum of all this chi-square value. If we do the sum of all this chi-square value, so what we will get, let's come back. I'll come back to this table again. So see here. So this is how we calculate the chi-square value. Once we get the chi-square value, these are the chi-square value, it is given here. So the sum of all this chi-square value is 14.28. Okay, when we chi-square, we will have to find out the sum of all chi-square, that is my total chi-square value. So total chi-square value I got is 14.28. Now I will have to see it in the, whether this 14.28 value is a significant value or not. For that we will have to consult the chi-square table. We will consult the chi-square table. What is the degrees of freedom for that? How many rows and how many columns? It's a m minus 1 into n minus 1. So 3 minus 1 into 2 minus 1. So my degrees of freedom is 2. Okay, the degree of freedom in this case is 2. So for 2 degrees of freedom for value 14.28, if you see the chi-square table, what you will see, the p value, the probability for that is basically less than 0.0001. If you see the chi-square, I am not showing the table here, I have showed it many times. I am sure by now all of you are comfortable with that. So if you consult the chi-square table, you will see for this 14.28 with 2 degrees of freedom, it has a p value of 0.001, very less. So and significance value usually we consider around 0.05. So 0.05, and this is less than that, 0.001. That means if we draw the something here, this is my significance level. If it falls in this area, then I reject the null hypothesis, and my value is falling here, much lesser than the significance value as well. So that means I reject the null hypothesis. That means the researcher rejects the null hypothesis and accepts the alternate hypothesis. There is difference in occurrence of pneumococcal pneumonia between the vaccinated and unvaccinated group. That means there is the vaccination has the, what was my earlier question, does it have this vaccination, does it have any effect on the occurrence of pneumococcal pneumonia? Yes, it has an effect on the vaccination has an effect on the pneumococcal pneumonia in the people, because null hypothesis does not have effect, alternate hypothesis it has an effect. Now this story does not end here, right? That is one of the beauty of chi-square distribution, I should say actually. So here from this, okay, we found out that okay, we rejected a null hypothesis, but we got the chi-square value by taking the sum of which cell has contributed to this rejection. We can find that out. We can go. In earlier tests, there was no specific which data has contributed to this. Now we can find out which cell has actually contributed to the rejection of the null hypothesis. Now if we go back to our table, see whichever column we get a chi-square value high, we got a chi-square value greater than 1 is in this and this. Rest all are, this is very much less than 1, very much less than 1, this is less than 1, and this is just 1. For these two value, we got a chi-square value which is very much bigger than 1. What the highest value of chi-square is 6.08. Why did I get a highest value of my such a highest value? Because you see here my expected value, considering that the vaccine has no effect, my expected value was 14.34. I expected if vaccine did not have any effect, then I expected that the people will have this type of pneumonia around 14.3. But how many people had? Only 5 people had. So this cannot be by chance. This cannot be a random event. There has to be a significant value. Expected is 14.34 and people who got is very 5. That means vaccine had an effect. That's why we got such a less value. Whereas if the vaccine did not have an effect, the expected value was 14.34. Similarly, next highest value is here 5.95. Chi-square value of 5.95. Here see our expected value is 14.66 and how many observed value is 24. This also it cannot occur by chance. So if the vaccine did not have any effect, the expected value is we are expecting people around 14.66 people will be having the pneumonia, that type of pneumonia, particular type of pneumonia for which the vaccine has been developed. But the number of people who actually had that pneumonia is 24. So this cannot be a value by chance. It doesn't. We cannot just consider it a random event. So that means the vaccine has an effect. That's why people who has taken vaccine, the people, very less people got the disease, whereas expected is so high. And similarly here, because vaccine have an effect, say these people since they did not take any vaccine, so though the expected value was 14, but 24 people had the disease. Okay, and rest all the values it is very lesser than 1, just one value is just 1. So it will not, this other cells did not contribute to our decision. The only factor which contributed to our decision is this cell only, this cell 1 and cell 2. Okay, so interesting, right? This is how we find a chi-square distribution. We can not only be able to tell whether this there are some sort of correlation or not, we can also specifically point out this presence of this correlation is for which of the category of data basically. So this is by using correlation using chi-square distribution. Okay, so quickly we will go to the other problem. Now the thrust of an engine is a function of exhaust temperature. Y is a function of x basically in degree Fahrenheit when other important variables are held constant. Consider the following data. Fit a simple linear regression for the data and find the equation of the regression line. So we are just asked to fit a simple linear regression for the data and find the equation of the regression line. So fitting the data to a simple linear regression is that we don't have to do anything, just we know simple linear regression expression is y is equals to alpha plus beta x. Y is equals to alpha plus beta x. So we know what is alpha, we know what is beta, we have already calculated using the least square estimation method, isn't it? So this is the data, we can just use the scatter plot just to see and see for the alpha and beta, that value which we have assumed. For beta we have assumed B, for alpha we have assumed A. These are the values we have calculated using least square estimation method. We have done it, I think in the last class only, we have last lecture maybe. So this is the B, this is the parameter B, this is the parameter A. So we have here what we need xi, x bar, yi and y bar. From the data we can find out xi, x bar, yi, y bar is nothing so great. So we found out the data, we found out the A value, we found out the B value. Once we found out the A value and the B value, our equation is nothing but this, whatever this is, see this is our A value plus B into x. This is my expression. So this is my linear equation line, regression line. Cool, right? Just we need to remember what is B, what is A. If you don't want to do the whole process of least square estimation, then minimizing the least square estimation, how do you minimize it by doing first order derivation, partial first order derivation with respect to each parameter once, then equalizing it to 0 and then finding out the value. Instead of, if you want to do it great. If you don't want to do it, just still have to remember this formula. From there only we got this A and B value. There is no rocket science here. So next question, in a particular village the production of rice is primarily dependent on the rainwater only. In a survey, the amount of average daily rainfall and the total amount of rice production is recorded. So it is this is the rainfall and this is the rice production. in one particular year 4.8 mm rainfall is recorded. In a particular year 4.8 mm rainfall is recorded. Can you predict what would be the rice produced? Simple question of regression analysis, isn't it? Given the value of the independent variable, we will have to find out the value of the response. So, how we will do that? For that we will have to need to know the function. That means we will have to find out the regression line, that is y is equals to alpha plus beta x. That means we need to know the value of the parameter, that is alpha and beta. How we will know the value of the parameter? That's the way we have done in the last example. Same way, find out the value of the parameter. Once we know the value of the parameter, we got the equation. Once we got the equation, in the equation put the value of the x and you will get the value of the y. Cool. So, this is b, this is a. We calculated b and a. So, this is our expression. This is the linear regression line. Now, here given our the x value is 4.8 mm. So, I put 4.8 mm in x, then what value you get? For y you get 123 ton. Okay. So, that is all. It's a very simple tutorial, isn't it? So, this is the reference, and thank you guys.